vector strength reduction formulated before SSA form, we distinguish between two kinds of induction variables, namely basic induction variables and dependent induction variables. A basic induction variable is one which is incremented each loop iteration by a constant. As we will see, the SSA formulation does not require this to be a numerical constant, a literal. It's sufficient that it's a variable which does not change in the loop. The other kind of induction variable, dependent induction variable, is we have an example of it here, which means that it's multiplied by a basic induction variable and possibly incremented by a constant as well. So it's on this form. And we want to get rid of this multiplication. How to do that? Well, we can simply observe that the value of s will be the same if we increment s with this factor whenever we increment I. And of course we also need to initialize s to its proper start value. So this is very simple. The question is now, how can we get rid of this I, because it's not used for anything? We can rewrite the loop using something called linear function test replacement. Okay, so we express the loop termination condition in S instead of in I, and therefore we can get rid of the I. Well, we use it to initialize S, but we don't use it any longer. And this is of course a good thing, since we, one, get rid of an add instruction, and two, get rid of a register requirement for I.